Up to this point in this class, we haven't graphed much more than a simple line. In this chapter, because we have quadratic variables, we're going to graph a more interesting shape. We're going to graph what's called a parabola. Let's look at our first equation. We're going to graph y equals 2x squared. Notice we have a quadratic term, x going to the second power. Now, if you were given no other instruction but to graph, what would you do? Well, hopefully you would at least draw yourself the coordinate axis. Remember, the horizontal is called the x-axis, the vertical the y-axis. And then hopefully you would at least try to draw a table of values and try to see what is this thing going to look like. So what we're going to do is choose some values for x, calculate some values for y, and then plot the points. Now, an interesting one to always plot is to let x equal 0. So when I let x equal 0 here, I get y equals 2 times 0, or simply 0. Let's just continue. If x is equal to 1, this gives me y equals 2 times 1 squared, simply 1. 2 times 1, 2. Let's continue. What happens when x is equal to 2? 2 times 2 squared, which is 4, times that 2 gives me 8. That's probably big enough because we're not going to be able to fit something much more than 8 on this axis. Now, we can't forget about our negative numbers. So let's try our negative 1. Now, when x is equal to negative 1, this gives me 2 times negative 1 squared. Negative 1 times negative 1, positive 1. Positive 1 times 2 is positive 2. In fact, if we inspect this equation, I hope you recognize that no matter what value, positive or negative, I put in here for x, y is going to always turn out to be a positive value, simply because we're always squaring that value for x. Now, let's continue and try negative 2. Negative 2 squared, positive 4. Positive 4 times that 2 gives me a positive 8. I think those are enough points to start our graph. Now, do you recognize a little pattern here? I have the ordered pair 0, 0. I have 1, 2, as well as negative 1, 2. I have 2, 8, as well as negative 2, 8. So it looks like what's going to happen when I plot these points is I'm going to be symmetric about that y-axis. What that means, I'm going to be equal distance with my points. So let's start to plot these. I've got 0, 0 here. I've got 1, 2, which is over 1, up 2. I've got 2, 8, which is over 2, up 8. Now this was 3, 4, 5, 6, 7. There's about 8. So there's my 2, 8. Now I'm down here at negative 1, 2. That's negative 1, up 2. Notice these 2 points are equidistant from that y-axis. And finally, negative 2, 8, which is over 2, up 8. Again, equidistant from the y-axis as that other point there. Now, this gives us a general feel for what our graph's going to look like. We could, if we want to, calculate many more points, but whenever we're graphing these quadratics, we know it's going to take the shape of a parabola, which looks roughly like that. It's kind of a U shape, if you would. Now, this lowest point here, at the point 0, 0, is called our vertex. That's an important point, because when we do some applied problems using our parabolas, this vertex here will represent the minimum values of some functions when they're facing up. And when our parabola is facing in the opposite direction, the vertex will also represent some maximum values. So besides the vertex, the other important properties of this parabola is that if I were to fold it here along the y-axis, notice that both sides would match up. This is the property of being symmetric. So our parabola is symmetric, and it has either a lowest point if it's facing upward. We could have parabolas that go in the opposite direction. If it does, then we say we have a maximum point. That's the basics of drawing a parabola. Let's try to graph one more. Let's start over here, and let's look at the following equation. Let's say this time we want to graph y is equal to x squared minus 4x minus 5. Now, to graph a parabola, I hope you recognize that what's important is to find that vertex point. And then we want to know whether or not that vertex, or excuse me, the parabola is facing in the upward direction or the downward direction. Now, to find the vertex of a parabola, you must memorize a very small formula. First of all, we have to make sure that our quadratic equation is of the form y equals ax squared plus bx plus c, which fortunately for us, this equation is already there. So since we're in standard form for a parabola, we can identify the vertex as follows. The vertex is going to have coordinates x comma y, and x is going to be found by calculating negative b over 2a. And what does this mean, negative b over 2a? Well, we've had experience with the quadratic formula that if the quadratic equation is in standard form, a is the coefficient of the quadratic term, b the coefficient of the linear term, and c simply the constant term. So in this case, if we want to use or find here the vertex of our parabola, the x variable is negative b over 2a, or in this case, that gives me negative 4 all over 2a, a of course being 1, the coefficient assumed to be 1 when there's no number there. So that gives me simply 2. So in this case, what's that telling me? The opposite of 4 is positive 4. Positive 4 divided by 2 gives me a positive 2. Now you say to yourself, well, that's good, you got that x coordinate, but we still need to find the y coordinate. So far we have 2 comma what? How can we find that what? Or how can we find the y variable? Well, notice if we go back to this equation, we now know the value of x of our vertex. X is equal to 2. So if we take the original equation and substitute the value in for x, we can then calculate the needed value y. So let's do that. Y is equal to x squared, but x we found to be 2, so that's 2 squared minus 4 times 2 minus 5. So in this case, y is equal to 4 minus 8 minus 5. So just adding these string of numbers gives us y is equal to 4 minus 8, negative 4 minus 5, there it is, negative 9. So what did we find here? We found that y is equal to negative 9. Now what does that represent? For us in this problem, this represents the vertex of our parabola. So now what we can do is we can draw our x and y axis, and we can plot the point 2, negative 9, and plot the point, this is our vertex. Now, we need to know whether our parabola is facing upward or going downward. It's as simple as looking at the coefficient of the x squared term. If the coefficient is positive, our parabola is going to go open facing upward. If it's a negative number, it's going to open facing downward. So we can be assured, because the coefficient of our x squared term is positive 1, our parabola is going to open facing upward. Now, one more thing to get how fat or skinny our parabola is is we can find the x-intercepts. We want to know where is our graph crossing the x-axis. Well, remember with me that all along that x-axis, the value for y is always equal to 0. Pick a point, 2, 0. Pick another point, 5, 0. No matter where we are on the x-axis, y is equal to 0. So if we want to find out where our parabola is going to cross that x-axis, we can take the original equation here and let y equal 0. So to find the x-intercepts, we're going to let y equal 0 in that original equation. So that gives me 0 equals x squared minus 4x minus 5. And thank goodness that's an easily factorable trinomial. That gives me, here we go, x minus 5, x plus 1. Using that zero factor property, either x minus 5 equals 0 or x plus 1 equals 0. So that tells me my two possibilities for x are 5 and negative 1. Now what does that mean? These two values are my x-intercepts. That means that my parabola will cross the x-axis at these two values for x. So here I go at negative 1, which is right here, and positive 5. 1, 2, 3, 4, 5. Notice that my vertex is exactly in the center. There's 3 to the right and 3 to the left because the vertex is exactly down that center line in our parabola. So I can finish my graph of my parabola by sketching up and crossing at x equals 5 and crossing again at x equals negative 1. So there you have it. The key here is remembering that the vertex x can be found by the formula x equals negative b over 2a. That'll give us the x coordinate of my vertex. Taking that value once you find it, substituting it into the original equation to solve for y. To find where we're going to cross the x-axis, that's called the x-intercept. We let y equal 0, solve that equation, plot those points, and just sketch your graph.